Hello everyone, today I'm going to do our videos about 20s integrals, and here is the integral we are gonna do today, and here is the answers, and the integral we are gonna do here, and we're gonna do 12 indefinite integral and a definite integral. And let's start. The first one is the integral of sine qx. And the first thing we're gonna write this as sine x times sine square x dx. And then so let's convert sine square x into 1 minus cosine square x here. So what I'm gonna do next, we can use our substitution. We let u is equal to cosine x, and then du is equal to negative sine x dx, right? So you can give it a negative here, but don't forget to add another negative to here because it will change the whole thing if we don't do that. So negative sine x dx is our du now, so you can replace it. So 1 minus and then cosine square, you get u square in our u row and then du. So you can get negative u, and then negative times negative become positive, plus 1/3, and then our u cubed here. So our final answer is, let me put a positive at first, so you can get 1/3 cosine qx minus cosine x plus c, and that's our answers. The first answers 3. And let me check the answers, and yeah, you see 1/3 cosine qx minus cosine x plus c. That's our first answers. First question. And here is our second question. The integral of x squared ex dx. This is our second question. And here, to integrate it, we're gonna use our integration by part method. We're gonna use our di method. Put the d and I here, and then plus and minus. And here we're gonna differentiate x squared and then integrate e power of x. The reason that we differentiate x squared because it will get 0 at the end. So to differentiate x squared, you get 2x, and to do it again you get 2, do it again you get 0, and then integrate, keep integrating, you get e power of x, e power of x, e power of x. So you can use this multiply by that, because you see the 0 is in the d column, so this is the first step of the di method. So we're gonna get x squared times e to the x, and then negative 2x times e power of x, and then positive 2 times e power of x plus c, and that's our answers. Let me check it. X squared e power of x minus 2x e power of x plus 2 e power of x plus c, right? So let's move on to our third question. The first two one is really easy, but let's move to a harder one. The integral of e power of 2x sine x dx. Okay, this is a very famous form, e power of x times sine x, or e power of x times cosine x. This is a very famous form. We'll get a repeat at the end. So To do this, we're gonna use our integration by part once again, d and I, plus and minus, and then plus minus. We're gonna differentiate e power of 2x, or you can integrate e power of 2x, up to you. This is my choice. And then we're gonna integrate sine x, and then differentiate e power of 2x, you get 2 times e power of 2x, and then keep going, you get 4 times e power of 2x. To differentiate sine x, you get negative cosine x. To differentiate, integrate, to integrate once again, you get negative sine x. When you see the repeat, you need to stop. Be sure this, when this time that, the integral of this is a negative sign, so you can move it to left hand side. So let me continue here. Negative e power of 2x cosine x, and then this time that become positive 2 times e power of 2x sine x, and then minus, because 4 is a constant, you can put it outside the integral, so you can get negative 4 times the integral of e power of 2x sine x dx. So we can move it to left hand side, so 5 times the integral of e power of 2x is the original, and we're gonna change the order up to you. You can also write the negative in front, but this is my habit. I like to write positive at first. 2 times e power of 2x sine x minus e power of 2x cosine x. So we can divide it by 5 on both sides. So the integral of e power of 2x sine x is equal to 2/5 times e power of 2x sine x minus 1/5 times e power of 2x cosine x. And don't forget to plus c, and this is our answers. It's only number 3. We have 17 to go. 17 more to go, and let me check the answers. 2/5 times e power of 2x sine x minus 2/5. Wait. I forget something here. This time that, and then this time that. Negative 2. Do I make any mistake here? Let me check Wolfram Melva. Let me type the integral. Let me try it. E to the x, e to the 2x sine x. Let me try it out. No. Yes. These are answers. I write the answers wrong, I'm sorry. This is the answers right here, and I write it wrong here, I'm sorry. So let's move to the next one. Next question. So on number 4, the integral of secant power of 3 dx. This is a very famous one. Secant power of 3x. I recommend you to remember this integral because this is very, very common. So I'm gonna split it to secant x times secant square x dx here. So we can use our integration by part. Because secant square x is very easy to integrate. This is just, we're gonna differentiate secant x and then integrate secant square x. To integrate secant square x, you get tangent x. To differentiate secant x, you get secant x tangent x. So you get, this time that you get secant x tangent x, and then minus the integral of secant x times tangent square x. Tangent square x is equal to what? Yes, secant square x minus 1. This is our identity. So we can split it to two integrals. You get secant x tangent x, and then minus the integral of secant power 3 dx minus the integral of secant x dx. Here, so you see it repeat, you can move it to left hand side. So 2 times the integral of secant power 3 x dx is equal to secant x tangent x. If you don't know how to integrate secant x, you can check my other videos of how to integrate secant x. And this is negative, still negative, and then ln absolute value of secant x plus positive, so plus tangent x here. So we can divide it by 2 on one side, so you can get secant power 3x dx. The integral is equal to 1/2 secant x tangent x. But negative times negative is positive here. Be careful. Plus 1/2 ln absolute value of secant x plus tangent x plus c. I recommend to remember, I'm gonna put 3 star here. This kind of important. And then the integral of secant x is really important. You always see this. I'm gonna put 5 star. Okay. If you liked, you can copy the integral of secant power 3x and then the integral of secant x here. No, it should be here. This integral. The star should be put on the integral of secant x. So let me check the answers. This 1/2 secant x plus 1/2 ln absolute value of secant x plus tangent x plus c. Okay. I've cut code, so wait a minute. My stuffing will suck. So number 5. So our number 5 integral, the integral of inverse x. Inverse x. Oh, so many integration by part question. So we're gonna differentiate. We don't know, if we don't know how to integrate inverse x, we can differentiate. Because we have a formula of this, it's just 1 over square root of 1 minus x squared. And then to integrate 1 is really easy, you get x. So this time that you become x time. Always write the x first, because it's more beautiful. If you write x as this, it will be very crazy. It seems like this sine inverse sine of x times x is just inverse sine of x squared. So I recommend to write x as first. So and then you minus the integral of this. So x over square root of 1 minus x squared dx. So here, how can we integrate it? So be careful. To differentiate square root of 1 minus x squared, first we get 2 times 1 over x squared. And then because of the chain rule, you're gonna multiply by the derivative of 1 minus x squared. So it becomes negative 2x. So 2 and 2, they cancel each other out. So it becomes negative x over square root of 1 minus x squared. So this is just the one we need. So this is plus square root of 1 minus x squared plus c, and that's our answers. So you can check the answers. This was x times inverse sine x or r sine x plus square root of 1 minus x squared plus c, and that's it. The number 6 one is really similar. I'm not gonna erase this DI table because the next one is really similar. This time we're gonna integrate not cosine, not inverse cosine. It's inverse tangent x dx. So here we're gonna differentiate inverse tangent x. In the integrate 1 you get x, and then to differentiate inverse sine x you get 1 over 1 plus x squared. So it's become x times inverse tangent x minus, so x over 1 plus x squared dx. So this integral is just minus, and then this is inverse x, right? Inverse tangent x squared no, but what are we lacking here? This is not exactly inverse tangent x. This is actually L1. Because why? If you differentiate L1 of 1 plus x squared, first you get 1 plus x squared, and then because of the chain rule, you're gonna multiply the derivative of inside, you get 2x. But we don't have a 2, let me give it a 2 here. And then be careful, you're gonna multiply by 1/2 because it will change the whole thing. So you can get negative 1/2 L1 parentheses 1 plus x squared plus c. And here we don't need an absolute value here because L1 of 1 plus x squared, and then 1 plus x squared is always gonna be positive, so don't worry about this negative number inside. So that's our answers of the integral of inverse tangent x. So we should be faster. This is not actually a speed 1 video, but let me do it faster because. So this is our answers. X times inverse tangent x minus 1/2 L1 parentheses x squared plus 1. And then the next one, number 7. Number 7 is the integral of L1 of x squared plus 1 dx. This is really similar to last one because the last one, the integral of inverse tangent is, you see, we have L1 parentheses x squared plus 1 here. So it might be connected to inverse tangent is here. So how can we integrate? DI method. Once again, I like DI method so much. I'm gonna differentiate Ln of x squared plus 1 and then integrate 1 here. So to integrate 1 you get x. To differentiate this you get x squared plus 1, and then because of the chain rule you get 2x here. So you can get x times Ln of x squared plus 1 and then minus the integral of, because 2 is constant, you can put it outside, and then negative 2, and then x times x is x squared over x squared plus 1 dx. And here I'm going to add 1 and then minus 1 at the same time. So it becomes x times Ln of x squared plus 1. And then let me split it to 2 fractions. 1 plus x squared over x squared plus 1, it becomes 1. So minus 2 times the integral of 1 dx. And the next one is negative 1 over x squared plus 1. So negative 2 times negative 1 becomes positive 2 times the integral of 1 over x squared plus 1 dx. So overall you get x times Ln of x squared plus 1 minus to differentiate 1 you get x here, so over you get 2x, and then to integrate 1 plus x squared plus 1 over x squared plus 1, because the derivative of inverse tangent x is 1 over x squared plus 1, so the integral of this is just inverse tangent of x, don't forget the plus c, and this is our answers. Yes, this is the answers. Yes, yeah, right. So, what about the next one? 12 more to go. 13 more to go. The 8th one. This is really easy. The integral of 1 over square root of 4 minus x squared. Yes. And here, whenever you see the integral in this form, I recommend you to memorize this formula. The integral of 1 over square root of a squared minus x squared dx. This is just equal to inverse sine of x over a plus c. To do this integral, you can use your tri-sub to let x is equal to 2 sine theta, and then keep doing, you will get this. So use the formula you can get, and then 4 is just 2 squared, so you can get inverse sine of x over our 2 squared, and then our a is just 2, and then plus c, and that's our answers. So okay, I'm not going to read the answers to you guys anymore because it will waste a lot of time. So let me keep going. If this is a mistake, I will tell you, but I'm not going to show the answers to you. So the number 9, this is the hardest one. The square root, the integral of square root of 4 minus x squared dx. We also have a formula of the integral of square root of 4 minus x squared. Square root of a squared minus x squared, but this is very hard to remember, this formula. So I don't recommend you to memorize this formula. The easiest one is just 1 over square root of a squared minus x squared is become inverse sine of x over a plus c. And this is really hard to remember. So to do this integral, we're gonna use our trigonometric substitution. We let x is equal to 2 sine theta. That's why if you factor, you get 4 times 1 minus sine square theta here. So you can change this as cosine square theta. So dx is equal to 2 cosine theta d theta. So it's become, you can put a 2 outside the integral, and then square root of 4 minus 2 sine theta, and square like that. Then cosine theta d theta. So you can factor out the 4 here, and then 1 minus sine square theta cosine theta d theta. So square root of 4 is 2, 2 times 2 is 4, put outside the integral, and then 1 minus sine square theta is cosine square theta. Take square root, you get cosine theta, and then cosine theta times cosine theta, it become cosine square theta. And here we're gonna use our double angle formula, but in terms of cosine 2 theta here. So we're gonna change this to 1 plus cosine 2 theta d theta, but don't forget to multiply by 1/2 in front of the integral, so it's become 2. So you can get x here, distribute it, you get 2x, and then sine 2 theta, and then because of the chain rule, you're gonna multiply by 1/2. So 2 and 2 they cancel each other out, so it become it should be theta 2 theta plus sine 2 theta. So sine 2 theta, you can write this as 2 sine theta cosine theta. So we know what is sine theta. Let me draw a triangle, and this is a theta, and then sine theta is equal to our x. It's just our opposites over our hypotenuse. It is 2. So this thing is just, this is a Pythagorean theorem. It becomes 4 minus x squared. So theta is inverse sine, 2 times inverse sine of x over 2, and then plus 2 sine theta is just x over 2 here, right? And the cosine theta is just adjacent over hypotenuse, so it's become square root of 4 minus x squared over 2. So it's become, and then it doesn't change in front, and then 2 and 2 they cancel each other out. And here I would like to write 1/2 here, 1/2 times x times the square root of 4 minus x squared plus c, and that's our final answers. So let me check the answers. Yeah, that's the answers. Wow. We are going to get very crazy here. Very, very long. Finally, number 10. Number 10, I'm going to use a lot of space here because it is kinda annoying here. Number 10, the integral, again, square root of 4 minus x squared, but in front we have an x squared here. So we're gonna let x is equal to sine theta, 2 sine theta once again, and then dx is equal to 2 cosine theta d theta. So we can replace x with 2 sine theta, and then square that, and square root. Because 2 is a constant, you can put it outside the integral, and then 2 cosine theta here, d theta, and then 4 minus 2 sine theta square. So it become, and then 2 square is 4, 4 times 2 become 8. And then sine square theta, and then square root of 4 theta, it become 4 times 1 minus sine square theta cosine theta d theta here. So it become, and then here 8 times square root of 4, and square root of 4 is 2, so 8 times 2 is 16. And then square root of 1 minus sine square theta is just cosine theta, so it becomes sine square theta times cosine square theta d theta. Oh, this is kind of tough right now. So I'm going to change theta this square here, and then sine theta cosine theta, we can change this to 1/2. Because it's in our theta world, we're gonna change this to 1/2 sine 2 theta. So you can put it outside the integral, and then it become 1 over 2, you square that, it become 1 over 4, so divided by 4, it become 4 times the integral of sine squared 2 theta d theta. So to do that, you divide it by 2 here, so it can become 2 times the integral of 1 plus cosine, and then 2 times 2 theta, it become cosine 4 theta d theta, according to our double angle formula in terms of our cosine, right? So it become 1, differentiate, you get 2, distribute 2 here, you get 2 theta, and then cosine 4 theta, differentiate, it becomes sine theta, sine 4 theta, and then 1 over 4, and then it become 2 times 1 over 4, it become 1/2. So sine 4 theta, do we have an identity of it? No, but don't worry, we're gonna write it as 1/2 sine 2 times 2 theta right here. So we're gonna get 2 theta plus 1/2 time 2 sine 2 theta, right? And then cosine 2 theta according to our double angle formula. 2 and 2 they cancel each other out, so it become 2 theta. And the sine 2 theta is very easy to convert. And then cosine 2 theta. How can we get rid of this? Cosine 2 theta. The sine 2 theta, we're gonna change this to 2 sine theta cosine theta. And then how about cosine 2 theta here? Let me think. Cosine 2 theta, we can change this to 1 minus sine square theta. 1 minus 2 sine square theta. And that's it. So we can draw a triangle here. And our theta, and then x over 2 here, and now this side is square root of 4 minus x squared. So it becomes 2 times the inverse sine of x over 2, and then plus 2 times sine theta is x over 2 times cosine theta is adjacent over hypotenuse over 2, and then we're gonna multiply by 1 minus 2, and the sine theta is just x over 2 and square that. So it become, this should be positive, and then 2 and 2 they cancel each other out, so it become 2 times inverse sine x over 2, and then plus 1/2 x. And here I'm gonna simplify it, and then 1 minus 2 times x squared over 4. So 2 and 4 they simplify to, and then this is just let me check the answers right here. Okay. And then let me write it as first. But we're gonna get the same denominator here. It will be more beautiful. So 2, and then 2 minus x squared here, and then multiply by 2 minus x squared over 2 times square root of 4 minus x squared. This is really similar to the last one, just simplify it. So you will see 2 and 2 they cancel each other out. Just kidding, because this on the denominator, so wait a minute. Yes, 1/4. But our original is, we don't have a negative here, right? Negative. Multiply inside, right? Oh, it should be negative here. Negative, so we'll get our answer, just switch the order here. So it becomes negative 1/4, positive 1/4. Our answer just factor it, put the switch the order, and then x times x squared minus 2 times square root of 4 minus x squared plus c. Ooh, that's the answers. I forgot to distribute negative sign here. That's the answers. Whoa. This is a long one. It's getting really crazy. This is so hard. Let's move on to definite integral, please. We have 2 more to go. indefinite integral. So number 11 is tri-sub again. Integral of x cubed over square root of 4, but this time is plus, be careful, this plus x squared. So we're gonna let x is equal to 2 tangent theta. So dx is equal to 2, the derivative of tangent theta, you get secant square theta, d theta. So you can put that 2 outside the integral first. And then x is just 2 tangent theta cubed over square root of 4 plus 2 tangent theta square that, and then multiply by secant square theta d theta. So let me just simplify it first, very fast, not first. And the square root of 4 times 1 plus tangent square theta, and then put it outside, get square root of 4, and then 1 over 2, cancel each other out, the 2 and 1/2. And then 1 plus tangent square theta, it becomes secant square theta, and then take a square root, it becomes secant theta. So we integrate thing. And then 2 square is a here, and then 2 and 2 they cancel each other out. So you only get a here. And then you get tangent cubed theta, and then multiply by secant theta. How can we integrate? Let me use our integration by part here. In the tri-sub, we're gonna integrate secant theta tangent theta, and then we're gonna differentiate tangent square theta here. To differentiate tangent square theta, it becomes 2 tangent theta secant theta. Yes, we will get very good here. We will be, and then we get secant theta. So you can get a times tangent, or I like to write secant theta first. A times for secant theta first, times tangent square theta, and then distribute 2 times a becomes 16, and then tangent theta secant square theta d theta. Okay. How can we integrate it? Ask yourself. Yes, use our DI method once again. To differentiate, you get secant square theta, right? I'm gonna erase this table, so it will help me to just use our integration by part once again. Integrate secant square theta, and then differentiate tangent theta, you get secant square theta, and then integrate it, you get that. You get the original bad. Wait. You get the original bad. That's not okay. This is a repeat situation. So I'm going to use our substitution here. We let u is equal to secant theta here. So du is just our secant theta tangent theta d theta. So it becomes a times secant theta tangent square theta. We don't need to change this to secant theta. You see why? Because I'm going to put it inside, put the number. Because we are in the theta world. I'm going to change this to x world later. So tangent secant theta tangent theta, we only get u here, u du here. So you get a secant theta tangent square theta minus 1. We're gonna divide it by 2 here, so you get a here. A secant theta times tangent square theta minus a, and then u square. U square, u is just secant square theta. Change to secant a times secant square theta. Finally, we're gonna draw a triangle here, and then we're gonna draw a right triangle, and then angle theta here, and then tangent theta is equal to x over 2, opposites over adjacents, and then the hypotenuse is square root of 4 plus x squared. And then secant theta is just this, multiplied by hypotenuse over adjacents, multiplied by, put the parentheses here, and tangent theta, x over 2, square that, minus a times secant theta, square root of 4 plus x squared over 2, square. So 2 square you get 4, 2 times 4 you get 8, and then and they cancel each other out, so you can get x squared times 4 plus x squared, and then let's say you get 2 square you get 4, and then reduce this you get negative 2 times 4 plus, but don't forget to multiply inside, because you have a square root here. So 2 multiply inside become a, and then negative, be careful, there's a negative here, negative a, and then minus a x squared, that's c. Yes, that's our answers. The original just doesn't reduce it. Just fatter. The original they fatter. Original answers fatter. So that's, but I would like to check the answers. I don't seem this is white. And we use our mat. You see this integral. The original is 1/3. Don't make some mistake. 4 times 2, and then cancel each other, x squared, and then 2 squared you get 4. Oh! Do I make a mistake? I don't think so. Just leave that you. If I make a mistake here, you can tell me in the comment section. And here is the answer, because I don't want to check the answers. This is very hard. These are advanced tri-sub question. Waste our time. Yes, our last indefinite integral. Integral 12, the integral of psi L1x dx. This can solve by using substitution, but this can also used by integration by part. This integral. So we're gonna, but let me use the substitution, because I know you guys are tired of seeing the method, integration by part of all the time. So we let u is equal to L1x, our du is equal to 1 over x dx, and then dx is equal to, and then our x is just e raised to the u, so dx is equal to e power of u du, so it's become e to the u multiplied by psi u du. So this is, I recommend you guys to memorize this. This is just 1 over 2 e power of u psi u minus 1 over 2 e power of u cosine u. And then if this is e to the u cosine u, you get 1 over 2 e power of u sine u plus 1/2 e power of u cosine. This is my personal experience. I always see this integral e to the u sine u and then e to the u cosine u. You can just change this to this. But in the exam, I recommend no. Just use our DI method or something. Integration by part. So we can replace it. And then 1/2 e to the u is what? E to the lnx is just x, and then sine of lnx minus 1/, e to the u, e to the lnx, you get x, and then cosine of lnx plus c, and that's our answers. Oh, finally, this is our last question of indefinite integral. We're gonna do some definite integral on my next video. Whew. This video is long enough. I don't think I have enough space to upload my next video, so I'm sorry to say that. The next video is questions 13 to 20, and stay tuned. Bye.